age 16, Elizabeth Sulzer had a very peculiar realization while she was out with a friend. It was when it started raining and the first landing drop sounded like the musical note G. In addition, the G let off a blue hue. When it started to pour the rain, Elizabeth was engulfed with colors in every note from the musical scale. She then asked her friend if she saw colors while she listened to music. It was then that they both realized that Elizabeth Sulzer was a little bit strange. It would be many years later before Elizabeth realized that she had a condition, a special ability known as synesthesia. The Dictionary.com definition of synesthesia is a condition in which one type of stimulation evokes the sensation of another. The brain of an individual with synesthesia works slightly differently than that of those with an average human mind, thus generating their special abilities. Synesthesia is a topic I've been very interested in for a few years now, and I've researched it multiple times. Synesthesia is an amazing condition that very few people seem to know about. At the end of the speech, more individuals will have the privilege to learn this, thus assisting in the expansion of the knowledge of the world around them. In order to accomplish this, I will start by jumping right into the brain. Neural sensory components of the average human mind functions differently from that of a synesthete. Next, the focus will narrow to a specific type of synesthesia known as intramodal modality, as there are several different categories within synesthesia. Last, I will finally reveal how certain everyday tasks are performed differently than synesthetes, especially in learning processes. There are advantages and disadvantages. To begin, let's take two separate neural journeys. In order to better understand synesthesia, we needed to look at the neural sensory components of the brain. Hull's Human Anatomy and Physiology by Butler, Shear, and Lewis will help us better understand this. Sensory regions are located in several different lobes of the cerebrum in a normal human brain. In order to interpret impulses for sensory receptors. In response, feelings of sensations are produced. The occipital lobe is the most important lobe of all of these when we're looking at sensory components. The occipital lobe is the most important lobe because when it comes to vision, hearing, and taste, which are all aspects of synesthesia. In addition, important areas include the motor areas in the frontal lobe and activation areas. Sensory and association areas help each other out sometimes. The parietal lobes have association areas that help interpret sensory information, aid in understanding speech, and choosing words to express thoughts and feelings. This is said by Shear, Butler, and Lewis again in Hull's Anatomy. Visual centers and association areas are located adjacently in the occipital lobes. Right here, as you can see, this is the occipital area. Recognition of visual patterns combined with visual images is what makes these adjacent areas so important. Since all these areas are all crowded together, a special occurrence known as cross-activation may occur. Cross-activation is researched and explained in the Cross-Activation at 10 article by Hubbard Bring and Ramachandran. It is right now the underlying theory for synesthesia. Cross-activation occurs when two independent neural functions cross one another to create a brand new and abnormal reaction. There is the inducer and the concurrent. The inducer triggers the response and the concurrent is the experience. As it matures, the average human brain undergoes synaptic pruning. Synaptic pruning, as you can see, is when you're a child at birth has less synapses and neurons. Then you have a whole lot at 7 years old, and then you have a little bit less at 15. These neurons and synapses that you use less are killed off. It's believed that synesthetes don't really undergo synaptic pruning, or they undergo less of it. So they have more of these synapses and neurons, which will cause those weird occurrences of cross-activation. Taking this information into account, you can see that cross-activation can occur in several different regions of the brain, which can cause several different types of synesthesia. But the main type of synesthesia is intramodal modality. Synesthesia is broken down into several different categories. Cross-activation in separate regions of the brain explains the reasoning for the large multiplicity of synesthetic types. There are four major modalities of synesthesia explained in Categorization of Synesthesia by Rogowsko. It consists of intramodal, intermodal, bimodal, and multimodal. The intramodal is the most common modality, and therefore is the most studied and tested type of synesthesia. Vilanar S. Ramachandra performed experiments and studied synesthetic individuals within this particular category. Ramachandran used subjects from the most common category of synesthesia, grapheme color, which makes up 68% of synesthetes. Grapheme color synesthesia occurs in response to cross-activation amongst two portions in the brain known as the grapheme selective and color selective areas. The adjacent sections of the fusiform gyrus is a structure that may potentially perform cross-activation on behalf of the involvement in color processing in regions. These are two regions which cause cross-activation. Is the grapheme and the colors. The color, this is the letters and the numbers, this is the color it produces. Using grapheme color scans, it was found that grapheme color synesthesia takes place in reply to activation in the color selective piece in the fusiform gyrus known as HV4. That is the entire area is HV4. Now that it's known that synesthetes' brain undergoes different neural processes, it's easy to guess that synesthetes may experience everyday life differently. Synesthetes undergo their life tasks, their everyday tasks can be a little bit different, especially when it comes to the learning process. They have advantages and disadvantages. And some of their advantages, one of them is that they can look at things spatially, such as like this. They can see calendars across them, so they can remember months and weeks, days of the week better than the average human being. But also it can be a disadvantage. Synesthetes see numbers in certain colors. So when they do math, they might get a different color before they actually get the numerical answer. They may think in colors instead of numerals, which can actually be a hindrance in simple everyday math. At this point, you have been informed of the neural components of synesthesia, the most common form known as the intramodal category, and how everyday life differs for a synthetic individual. This is only just an overview. There's so much more information to be discovered by you, me, and researchers alike. Mentioned before, synesthesia is a topic that very little people know about. The neural and everyday experiences of a synesthete differ from the average individual. The sensory components of the average human brain differ from that of a synesthete due to the cross-activation theory. Due to this theory, there's a plethora of sensories. The most common of these combinations is the intramodal grapheme color. There are so many people, places, and experiences out in the world that are foreign to us. Things that we may never know about. Learning about conditions such as synesthesia increases our understanding and knowledge of the world around us. Later on in her life, Elizabeth went in for a study of her brain. Doctors found that her brain was hardwired like no one else's. They found that there was a specific connection between the color area, the taste area, and the auditory area. Elizabeth had no exact idea what was happening to her, and was discovering new dimensions of her power every day. In the same way, researchers still haven't dug as deep as they can into the synesthetic brain. There is no doubt that there is potential massive knowledge on this